Hey, good morning, AP Stat students. I had to be away today, so we're going to do it this way, all right? I'm going to just take you through how we measure spread with something called the standard deviation, okay? You may have had some experience with the standard deviation, but you really got to have a good depth of knowledge on this concept. It's something we will use the entire year, I promise you that, okay? This is page 60 of the textbooks. So go ahead and get there. Maybe we can pause for a moment to let you get there, and then we'll continue. Okay, so last Thursday and Friday, we used the 5-number summary quite a bit to describe a distribution. Okay, we also created box plots with that. All right, your assignment from Friday, I'll check in tomorrow, so just hold on to that, and we'll see how that went. But that's not the most common way to describe a distribution. Now, if a distribution's skewed, we like the median better than the mean because we know the mean is not resistant to that skewness and outliers. But if that's not present, we do prefer the mean, okay? And the description of spread is not the IQR or the range, but standard deviation is used much more for spread, okay? So this is a big concept that we need to go through here, okay? So this example, 22, they asked some kids, how many pets do you own? Okay, 9 kids. Here's the responses. Here's a dot plot of that, okay? So what the standard deviation does is measures the spread. You know, the 5 was the mean, okay? So if we had a distribution, let's just say all the kids, hypothetically speaking, here's the responses, right, of the kids. It's tightly packed together. We would say this has a small standard deviation because it's not very spread out. And you understand once we go through the calculations of why this is going to be a small standard deviation. This is a little more spread out though. It goes from 9 all the way down to 1. So this is going to have a larger standard deviation. And here's why it's called standard deviation. Deviation, just kind of another word for difference. Okay, this student that responded with 7 pets has a deviation of positive 2 because it deviates by 2 from the mean of 5, okay, or distance, right? This student right here who responded 1 is 4 units away from the 5, right? So we call that a deviation of negative 4. So that's the whole idea of the standard deviation. Really, it's kind of like the typical distance of these responses from the mean of 5. Okay, I'll say that one more time. That's important. Standard deviation kind of gives us the typical distance from the mean of all of these responses. Okay. Okay, so let me show you how you calculate the standard deviation. All right, what we want to do is create a little table, and you need to show the work here for your OTI when you do it. So I'm going to list the observations right here. Okay, so that's just this raw data set, the 1 to the 9. Go ahead and do this as I'm doing it, please. Pause as needed if I go fast. Okay, so now we want to find each individual deviation. Okay, symbol-wise, this is going to be your individual x value minus the mean. Okay, when you do this on your own, they might not give you the mean. So you got to throw these in your calculator, divide by the number of data points you have to get your mean. Okay, it's given us 5. So basically what we have to do is take this observation of 1, subtract it by 5. And you got to go in this order, right? Because they're supposed to be negative when it's below the mean. Okay, so the kid that said 3, it's 3 minus 5 or negative 2. Once you get this going, you don't have to show all those minuses. I get it. We're just doing 4 minus 5, right? So this becomes negative 1 for a deviation. Or just think of it as 1 unit below the mean, 1 unit below the mean. 5 is 0 units away from the mean. 7 is positive 2. 8 is positive 3. This is positive 4, okay? All right, now to get the typical deviation, if we just added these up and divided by 9, these negatives and positives cancel, right? So that's why it's not a sound method of just adding them up and dividing. Okay, we don't want them to cancel. We want this distance to have a positive magnitude. So that's why they squared them. Okay, why did they take the absolute value? I'm not sure why, but they squared them to get this positive number. All right, so the squared deviations are going to be 16. Square this number to get 4. You guys can square these quickly as well. 4, this is going to be 9, this is going to be 16. Okay, let me peek ahead to the next page real quick. I was going to show you this right away, but I forgot. So here is the standard deviation formula. This is kind of what we're getting to. This is on your AP Stats formula sheet too. All right, this basically says right here, sum of squared deviations. Okay, it's a big part of the formula. Once we get through that, it's pretty easy. We divide by n minus 1 and take the square root. All right, so here's kind of your success criteria for how you find the standard deviation. Right, we're already into step 1. Find the distance of each observation from the mean and square each of these distances. We just did that. Okay. Step 2, average the distances by dividing their sum by n minus 1. So now we're on to this step. And then the last step is to take the square root. Okay. Before taking the square root, it's actually called the variance. We'll get there in a minute. The variance and standard deviation are very closely related. They're both measures of spread. This is the one we use more often though. Okay. Okay, so back to where we were. We have all these squared deviations. We have to find the sum of these squared deviations. Okay, so I can kind of put a line here, and we just got to add these up, right? I actually have that total for you. I know you know how to find sums of things. So we get squished right here. I'm going to come over here. Sum of the squared deviations. When I add that up, it gives me 52. Okay. Okay. So the standard deviation will be equal to the square root of, flipping this over just so you know I'm not just grabbing this from anywhere, right? The n minus 1 is basically in the denominator. They put 1 over n minus 1, but I like to just put it under this. So it's the sum of the squared deviations I'm rewriting it. I guess you don't have to if you don't want to. All over n minus 1. So I have everything I need now. It's 52 is going to go right here. N is the sample size, which was 9 students, right? Yep, 9 kids. And take the square root of it. So 52 over n minus 1, or just 8, right? Okay. So when we throw that in our calculator and figure that out, it comes out to be 2.55 approximately. Square root, this is 6.5 in my calculator, by the way, this number here. So this works out to be about 2.55 pets. Pause to catch up, and I want to talk about variance really quick. Okay, variance is standard deviation squared. This is the variance formula right here. Okay, notice it looks just like what's under the radical. It is. So the relationship of standard deviation and variance is just this. If you have the variance, all you gotta do is take the square root of it, and you get the standard deviation. All right, so it's what's under the radical. So if they ask you for what the variance is, it's the 6.5. Okay, so the variance is 6.5. We'll talk about that a little bit more tomorrow, but if they ask any of your questions, just make sure you know it has a squared relationship with the standard deviation. Okay, that's it for today. I'll give you your assignment to work on here. A little bit of review as well, 1.3. We're almost done with 1.3. Really I want to clean up some of these characteristics. Okay, so before you start your assignment 2, I want you to read up on these characteristics of standard deviation we have to have down. Important characteristics and properties that will come up on your test. So we're just going to review tomorrow, okay? And we'll have our test on Wednesday, it's looking like. All right. Okay. Have a good day. See you tomorrow.